Hi, Honors Algebra 2 students. We're in Chapter 7, Day 9 Notes, which focuses on products and quotients of rational expressions. One of the things that the last few lessons has focused on is factoring polynomials. Now we're going to take a look at rational expressions and be able to multiply and divide rational expressions and simplify the result. Our instructions say perform the indicated operation. And as we take a look at this first example, you can see that we have two rational expressions that are multiplied together. And keep in mind, a rational expression is just basically a fraction. And in this case, we're going to multiply those two fractions together. Now you already know that when we multiply two fractions, we typically multiply the numerators together and we multiply the denominators together, and then we simplify between the numerator and denominator to get our final answer. You also know that we can simplify first if possible, and then we can do our multiplying. So that's the approach we're going to take with these rational expressions. We're going to do some simplifying first if possible, and then we're going to do our multiplying. So in general, what we'll be doing is we'll be taking each numerator and denominator and factoring it if possible. And then we will take any common factors that we see between the numerator and denominator, and we will simplify those by canceling those. And then we'll carry out the resulting multiplication, keeping in mind that a rational expression is considered to be completely simplified when its numerator and denominator have no common factors other than 1. And then you'll see that we'll follow a similar process for division of rational expressions. All right, so let's get started with our first example. Let's take each numerator and denominator that we see and factor it. In some cases, you're going to see that there's no factoring that I can do. So 2 divided by x minus 2, there's no further factoring that I can do, but x squared minus 4, that's the difference of two perfect squares, so that will factor into x plus 2 times x minus 2, and then of course my denominator of 4 will remain as is. All right, so we have each numerator and denominator fully factored. Now we're going to see if we can simplify between the numerator and denominator. And by simplifying, what we're looking for are common factors between the numerator and denominator that we can cancel out. And just by way of reiterating, canceling in a fraction, or in this case a rational expression, means that we're dividing the numerator and denominator of that fraction or of that rational expression by the same common factor. Okay, so if we look for any common factors in the numerator and denominator, if you notice this x minus 2 right here, keep in mind that is a factor in and of itself. In other words, that goes together, the x minus 2. So you might want to put parentheses around that. But if we look for common factors in the numerator and denominator so that we can cancel them out, or in other words, divide them, we have an x minus 2 in the numerator, we have an x minus 2 in the denominator. So we can cancel those out. In other words, x minus 2 divided by x minus 2 is 1. In addition to that, if you look at the 2 in the numerator and the 4 in the denominator, we know that those are both divisible by 2, so we can do a little simplifying there as well. All right, well, if we now take our numerator and what remains, which is x plus 2, and we take a look at our denominator and what remains, and we just have a 2 left in our denominator, we want to write our final answer as one simplified fraction. So our final answer in this case is going to be x plus 2 all divided by 2. All right, now one thing I want to mention about this final answer, sometimes students will say, but wait a minute, we haven't simplified it completely. We can take this 2 that's in the numerator and divide it by the 2 that's in the denominator, and that becomes 1. All right, well, we cannot do that in this particular case because this 2 is attached to this x through addition, not through multiplication. So in other words, if it was 2 times x divided by 2, we could cancel the 2's out. But since this 2 is attached to this x through addition, we cannot do that. Or if it were even attached to the x through subtraction, we cannot do that. So one way of thinking about it is this x plus 2 goes together in its entirety, and because the relationship between the 2 in this case and the x is through addition, or if it were through subtraction, we cannot do that simplifying that you might be tempted to do. We could do it if the 2 was attached to the x through multiplication, but not if it's attached together through addition or through subtraction. Before going on to the next examples, I want to highlight the process that we followed in this first example because we will be doing something comparable in all the other examples. So first, we factored each numerator and denominator if possible. Then we simplify by eliminating common factors between the numerator and denominator. In other words, we canceled out common factors between the numerator and denominator by dividing them. And then we wrote our final answer as a simplified rational expression, keeping in mind that a rational expression is simplified when its numerator and denominator have no common factors other than 1. In our next example, we have a rational expression divided by a rational expression. Okay, so you know that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So what we're going to do is we're going to write the first rational expression as is, and then we're going to multiply by the reciprocal of the second rational expression. Okay, so I paused the video for just a moment and I wrote out what I just said. I took the first rational expression and wrote it as is, and then I multiplied by the reciprocal of the second rational expression. Next, I'm going to factor each numerator and denominator if possible, so feel free to pause the video and do that on your own. All right, so as you can see, I could factor x squared plus 4x plus 3 into x plus 3 times x plus 1. Everything else was already factored. There was nothing else I could do with the remaining numerators and denominators. Next, I'm going to simplify by canceling common factors between the numerator and denominator. So I have an x plus 1 in this numerator and an x plus 1 in this denominator, so I can cancel those out. Now that I've done my simplifying, I'm now going to do my multiplying of these two rational expressions together. And then I'm going to write my final answer as x plus 3 times x plus 5, all divided by 5x. All right, and notice that this rational expression is completely simplified because it has no common factors other than 1 in its numerator and denominator. And one more comment on this final answer. You can leave your final answer written in factored form like this one is. If you want to FOIL out the numerator and have it be x squared plus 8x plus 15 all divided by 5x, that's fine, but I'm completely fine with you leaving your final answer written in factored form as this one is. In our next example, we have a rational expression divided by another rational expression. So let's rewrite this as a multiplication problem. In other words, the first rational expression multiplied by the reciprocal of the second rational expression. Okay, so I paused the video and did what I just mentioned. I changed this to a rational expression multiplied by the reciprocal of the second rational expression. All right, now as we look at factoring each numerator and denominator, this is factored, this is factored, this is factored, and this is factored. But let's take a closer look now that they're factored and compare them. So here's what I mean by that. This x plus y is the same factor as y plus x. If we look at this x minus y and this y minus x, they are not the same factor, but they are opposites of each other. In other words, we have x minus y here, y minus x here, and they are opposite. So let's take a look at seeing if we can make them the same factor by doing a little bit of factoring with this one, and here's what I mean by that. Okay, so I paused the video and wrote a few of these factors as is. So x plus y is going to remain the same, x minus y is going to remain the same, and then y plus x is going to remain the same. Now I'm going to focus on further factoring this y minus x, and here's what I mean by that. If I factor out a negative 1, I will be left with x minus y. And then let's do some comparisons between our factors. So as we said before, this x plus y is the same factor as y plus x. Now if we look at how the other ones compare after doing our little extra factoring that we did right here, if we take a look at those now, this x minus y is the same factor as this x minus y here. So now, as a result of the extra factoring that we did right here, let's look to see if we can simplify by canceling out common factors between the numerator and denominator. So if we take a look at this, we have an x plus y as a factor in this numerator and a y plus x as a factor in this denominator. Those are common factors, so we can cancel those out. And then we have a factor of x minus y in this denominator and a factor of x minus y in this numerator. So we can cancel those out because they are a common factor between the numerator and denominator. And then if we take a look at what we have remaining, our final answer is going to be -1. All right, and one last thing to reiterate in this example. If you have factors that are opposite of each other, which we did in this case, we had an x minus y and a y minus x. Those are opposite of each other. Make sure you keep factoring, as we did right here, by factoring out a -1, so that you then have a common factor, and then your final answer can be completely simplified. In this next example, we have a rational expression multiplied by another rational expression. So I would encourage you to pause the video, take into account all the things that we've done so far on the examples up to this point, do the work on your own, and then restart the video and check your answer. Okay, so let's see how you did. X squared minus 3x minus 4 factors into x minus 4 times x plus 1. 3 plus x is already factored, x plus 3 is already factored. 16 minus x squared factors into 4 minus x times 4 plus x. All right, so at this point, we can simplify by canceling out the common factor of 3 plus x and x plus 3 in this numerator and denominator. Then if you compare this factor of x minus 4 and this factor of 4 minus x, those are opposites. So if we further factor this 4 minus x into factoring out a GCF of -1, with the remaining factor being x minus 4, we can now then have a common factor of x minus 4 in this numerator and x minus 4 in this denominator. In other words, those are common factors, so we can simplify those by canceling them out. And then if we now see what we have remaining, in the numerator we have an x plus 1, and in the denominator we have a -1 times the factor of 4 plus x, or x plus 4 as I wrote it in my final answer right here. So this is our final answer right here. If you want to distribute this -1 in the denominator, you can. If you want to write that -1, in other words, perfectly out front in the middle of this entire fraction or rational expression, that is fine. I will usually just leave my final answer written as you see right here. In other words, there are various mathematically equivalent versions of the final answer, but in any of those, we just need to make sure that our final answer is a rational expression that is completely simplified, meaning that there are no common factors other than 1 between the numerator and denominator. One more thing I just thought of before going on to the next example. I want to reiterate right here that we are not going to go through and cancel out these x's right here. Sometimes I've seen students do that, and I want to reiterate that we are not to do that here. As I mentioned on the first example, there's something comparable here. X plus 1 is a factor. It goes together. X plus 4 is a factor. It goes together in its entirety. In other words, the x and the 1 are attached through addition. The x and the 4 are attached through addition. So I cannot just take these x's and cancel them out. X plus 1 is a factor in its entirety. X plus 4 is a factor in its entirety. It needs to stay together. So they could only be further simplified if there was another common factor of x plus 1 in its entirety, or another common factor of x plus 4 in its entirety. And what I just mentioned about the x and the 1 and the x and the 4 here being attached through addition, and therefore x plus 1 is a factor in itself and x plus 4 is a factor in itself. The same would be true if this were an x minus 1 right here, or an x minus 4. If these are attached through addition or subtraction, then they are factors in and of themselves, and you need to leave them together in their entirety. In our last example, we have a rational expression divided by a rational expression. So I would once again encourage you to pause the video, do the work on your own, and then check your final answer. All right, so let's see how you did. I wrote the first rational expression as is, and then multiplied by the reciprocal of the second rational expression. All right, and then if you look, our numerators and denominators are factored. We potentially need to look into this in just a moment, but at this point, numerators and denominators are factored. So let's take a look to see if we can simplify by way of finding common factors between numerators and denominators that we can cancel. And if you look, we have an x plus 8 that's in this numerator, and it's a common factor with an x plus 8 in this denominator. So we can simplify those by canceling them out. All right, and then if we look at this x plus 5 factor and this 5 minus x factor, you may look at those and say, well, those are opposites of each other. So let's factor out a negative 1 from this factor of 5 minus x. And if we do that, we have a negative 1 times the remaining factor of x minus 5. Well, if you look, that is not a common factor. This is an x plus 5 right here, and this is an x minus 5 right here. So these are not opposite factors. And as such, there's no further simplifying that we can do between them. So if we look at what our final answer is, our final answer is x plus 5 in the numerator divided by 5 minus x in the denominator. All right, so by way of summary, as far as the process for multiplying or dividing rational expressions, take a look at the original problem. If it is a division problem, I would suggest rewriting it as the first rational expression multiplied by the reciprocal of the second rational expression. Then once you're working with a product of rational expressions, which would be accomplished either it was that way in the original problem or you turned a division problem into a multiplying problem. Once you're working with multiplying of rational expressions, your next step is going to be to factor every numerator and denominator if possible. Then your next step will be to simplify by eliminating common factors between the numerator and denominator by canceling them out. Then you should actually do the multiplying of the two rational expressions, meaning that whatever remains in the numerator you should multiply, whatever remains in the denominator you should multiply. Then keep in mind that your final answer should be completely simplified, meaning there should be no common factors other than 1 between the numerator and denominator. Also keep in mind, if you have multiple factors remaining in your numerator or denominator, you can keep your final answer in factored form. Okay, so this completes the Day 9 notes for Chapter 7.